Today let us discuss about DSO. So DSO is nothing but data store objects. This data store object is an info provider. I think we know that info providers. Info provider is what? What are the different info providers that we know? Info provider is nothing but it contains the data in BW system. Data in BW system. That means when we extract and transfer the data and extract, transform and load the data, we will be loading that data into any of the info providers that we have, and from this info providers these can be used as a source for the reporting purpose. So reports can be generated based on the data available in these info providers. Info providers contains data in BW system, that is what? That means which can be used as a targets to load the data from source system into our BW system for further processing or further reporting, and reports can be generated based on the data available in this info provider. What are the different info providers that we have? The basic info providers are, as we discussed earlier, the basic info providers we have are what? The last class we have discussed, no? So we have basic info providers as info objects, right? Then we have info cube, then we have data store objects, and we have some derived info providers, which are not basic info providers, but they also can be helpful for storing the data. They don't actually store the data, but we can get the data union into that, and we can report the data from them. They are info sets, and you have multi providers, you have remote and virtual cubes. So these are the other info providers that we have. So we have discussed about the info objects and info cubes earlier in the earlier classes. Now we will be going and discussing about the data store objects, right? So what is this data store object? So data store object. So we used to earlier call it as operational data sources as well. Prior to BW 7.0, we used to call them as operational data source. In short, this is a DSO and our operational data store, that is ODS object, right? So both are same in the meaning, but only it was the earlier name and this is the new name that we have after the new version of BW system came up, BI system. So that is our BI 7.0 onwards, we are calling it as operational data source. So whatever maybe the name it is having, right? So how will it work and what is the significance of this operational data store in this case? So this operational data store or DSO data store object, it is a two-dimensional table. That means it is a flat table. So on the contrary, when we have discussed about the InfoCube, we have discussed that InfoCube is a multi-dimensional. It is a multi-dimensional object. But when it comes to the DSO is a two-dimensional flat table. And do we really use this two-dimensional flat table for the reporting purpose? Yes, if you really want to develop the reports, it can be used as source for reports. Used as a source for reporting. But generally we don't use or we don't generate the reports based on this data store objects, and this data store objects we are going to use it as what? We are going to use it as a staging object. Staging, we are going to use it for the staging. What do you understand by staging? Yes? What do you understand by staging? Staging means it is a place where we are going to clean the data, cleans the data or consolidate the data before sending it to the target. Before sending it to the final target where you are going to save the data. I want to perform some operations and clean my data wherever if I feel that data is not directly stored into my cube or my target as it is in the same format, whatever the data that I am going to get. For example, if I am getting a customer number, I am getting the customer number from source system as suppose 0001234, but my target, as per my standards in the target side, I have to store only 1 2 3 4 5. I don't want to store, I have to store only 1 2 3 4 5 in target. That my source customer number, source system is giving me customer number as, right, customer number as 0001234, and I have to store only 12345 into target. This is a just simple example to make you understandable about the cleans the data. What does it mean by cleans the data? So this you can write some code, write a routine. That code we will call it in the BW terminology as a routine. You can write a routine to cut down or to truncate all the leading zeros. You can write some code to truncate all the zeros, and once you clean this at the stage of ODS or in the ODS, you can finally store your data into your cube. That is one. And the other thing is you can add the data or you can consolidate the data from different sources. You can get the data from different sources and consolidate into single source as DSO, and then finally into your queue. So this is another thing, because you might be having different source systems. For example, you have a flat file source system, you have SAP, you have the non-SAP ERP source systems, but you maybe need to get the data from different sources. For example, you have some POS, that is point of sales, at the different branches, which is a different software, and you are getting the data into some your ERP system or your database system. So that database, you want to get it from the POS database into some place, and you have the purchasing data from other place, and you in the SAP you want to get the data as well. So you have to consolidate the data from the two different data sources. So you cannot do directly this consolidation of the data source, consolidation of the data directly in the cube, where you are going to finally store the aggregated data, right? So we have to do it. So you can create the two different data sources, get the data, and get the data into two different data store objects, and from that two different data store objects you consolidate the data into one single DSO, and from that DSO you can just send that data into your cube. So that is what your consolidation. We will be going and discussing some more things about all these things, right? So this is the reason for staging. When you are doing the staging, you can clean the data and you can consolidate the data. For this purpose, you can use data store object. So you may ask me that, can I do this on my PSA and through the transformation I can directly? You can do that, but again there is a little problem in that. So when you are coming to the DSO, your DSO is going to have a permanent it will be holding your data there, right? And which will be generally used whenever you are going for the delta operations. This is very much useful, because the data in the data store object, you can overwrite the data in DSO. How this is going to be helpful for me, we can discuss when we are discussing about the standard data source object. So these data store objects, these data sources, the data store objects are three types. One is the first one is standard DSO. Then second one is your direct update DSO or real time DSO. Then finally you have the write optimized DSO. Now we will discuss about the standard DSO today in this class. In this class we can discuss about the write optimized DSO, the standard DSO. Standard DSO. So what is the structure of the standard DSO and how the standard DSO will work? So we will discuss all these things. So let me just align this to a little bit, so we can just spend some time. So this presentation I am going to share with you after the class. right? So, yeah, here we go. So what is the structure of this standard? Standard DSO will be generally whatever the DSOs that we are going to use for staging for the delta updates. We are going to use this for the delta updates. We are going to use this standard DS4 for the delta update for staging purpose. These are the most commonly used DSOs. Okay, most commonly used DSO. So what is the structure of this DSO and how the data is going to store in this DSO, we will see. As we have already discussed, a DSO is a flat table, and DSO is a flat table. This is your standard DSO. Right. This we can have this text in the middle. So standard DSO here, the structure. Standard DSO structure or architecture, whatever it may be, right? How it will be and what are the details that we can save into this and how they are going to store, what is its architecture inside. So generally the standard DSO will be having 3 flat tables. It is going to have 3 flat tables, namely, what are the names of them? Namely, active data, then you have change log and activation queue. Partition this into 2 and we will write the okay. Now we will see them here. You have your data here and another one is here. Third one is here. Right. So we have one thing that is, so this is going to be your active data table and this is your change log and this is going to be your active data activation queue, activation queue. So activation queue. So whenever you perform any transfer, whenever you perform any loading, so as soon as you perform on data transfer, whenever you execute any DTP, data transfer from PSA to, whenever you execute any DTP, the data will be transferred from PSA to activation queue. Activation queue, right? Once the data is transferred from PSA to activation queue, you need to activate the data, whatever the activation queue is having. Once you have to activate this data, activate data of the request, right? Data is coming with the request only. So when you activate this request, the data will be moved into active data table, and corresponding records will be generated in the change log table. So this means whatever the changes that you are performing, whatever that changes are performed of this during this particular request, they will also get updated in the change log. So once the change log is updated, if you have to further process this data into cube, the data from the change log will be updated into the data cube. So what will happen and how the data will be stored in these two areas we will see. For example, if you have two records, for example, you have a customer order number. This is the order number, this is the customer number, and this is the quantity and this amount. So this request is coming through request number 1, and it was already there in the first request. This was there here. Right? So this request is there in the request number 1, and same thing is updated here. Right? It performed one updation here. When you executed request number 1, it is also changed this record here. Right? And so corresponding change, corresponding updation also takes place in your change log. This is very, very important. In all the 3 places, whenever you perform any change, any updation takes place into this. So as soon as this activation, first immediately when you are just executed your transformation or the DTP, the data will be coming into this, and as soon as I activate this request or activate the data in this activation queue, so this will be getting, this particular thing will be vanished from here. This data will be vanished from here. You don't have the data in the activation queue. Your activation queue remains empty, and the corresponding record got updated here in the change log as well as in the active data table. So now after 1 day, so this is happened today at end of the day, and tomorrow again I come up and I was again updating the delta. So what happened is, the same customer, whatever the customer that I have here, he asked me to change his order. My order is not yet shipped, right? So what he asked is, he asked me to change this order quantity from 25 to 50. What happened when this change is taken place in the OLTP system? The source system data got updated, the same record got updated from 1, 2, 3, for the 1, 2, 3 for order number, customer 001, quantity is updated from 25 to 50, corresponding amount is updated from 25,000 to 50,000. So what happens? Now when I replicate, when I again execute this delta, right, every day I will execute the delta data source, so that my all updations will again moving into my BW. So now this is came here, I have the request number 2 here, right, my data in the activation queue. My data, when I again re-execute my data transfer DTP process today, the data is coming to my activation queue here. So from this activation queue, now I want to activate my data in the activation queue of the data store. So as soon as I just activated this data here, so data will be going from here. And what happens? Now this data has to go here, right? But what should happen here? Is this, if it is going and adding to this 25, it is going to be 55, 75. And here also it is going to be 75. If it is normally, when I update it into cube, it will happen like this, because the cube will aggregate the data. So what should I do? My data store object is giving me a facility to overwrite my data. So how this I am getting benefited, right? So this, when I do that, so it knows that I have a customer here, and this is request 1. Now I got the request 2. So when the request 2, what will happen? So already I have in the request 1, now I am getting request 2. So the request 2 data it is getting for this, right? So what it will do? Request 2 is also order number 1, 2, 3, 4. Request 1 was also for order number 1, 2, 3, 4. That means this is the key here. Order number is the key field, right, based on which we can differentiate the orders. So now the same order number it encountered with. If it would have been a different order number, there is no issue. But when it is the same order number, the same customer number it is, and the quantity is only changed. So yes, now this is going to write this record there also, because this one we have to update, right? So this record will be coming here, but as soon as it able to see, it is able to see here that it is having another record there. So what it will do is, it is not good that if I am just simply adding this record here, that will not suffice. So what it will do is, yes, earlier there was an order for the same customer, right? Same order number was there. So now it will create another record with quantity as minus 25. Minus 25,000 is the amount, because otherwise what will happen? So actual customer is only 50, placed order for only 50, but otherwise it will be 75. Earlier you have 25 and now you have 25 50. So that's the reason, when it is able to see that there is a key field matching quantity is available, it will try to override. This overriding, when it is trying to override that, it is created this minus 25. And when it comes to active data table, what will happen is override. So same key is there. So what it will do is, it will simply strike this order. So this record will be eliminated, right, and it will replace it with the new one. The old one will get deleted and only the new one will be here. And how this is helpful to you? This is helpful for me if from here, if I am directly updating the data to a cube, if I am going to update the data to a cube from here. Right, so that is one. Same thing here, we can also draw this to this. So here the data is going from activation queue to active data, and also from activation queue to change log, and in the change log you will be having one minus record, and when you feed this data to your cubes, we will be, so from this cube, if the data is going from this data source to cube, what will happen? Your cube is already contained this data of this. So immediately followed by that, you will be adding one minus record. So quantity 25 minus 25 plus 50. So your cube will be adding the data. So summation 25 minus 25 0 plus 50 50 you will be getting. So the same order still remains with only 50, and now amount 25 minus 25,000 is 0 plus 50,000. So that is means your amount and your quantity will be getting intact. This kind of facility, if otherwise if you would have directly stored this data into your cube, so as the cube is aggregating the data, earlier you have 25 quantity, now you have 50 quantity. It will sum up the data and store there. So that is the problem with your queue if you are not using a DSO when you are updating it. So guys, this is how we can be using DSO. This is what the description of standard DSO. In the upcoming sessions, we will be able to we will be discussing direct update DSO, write optimized DSO, and we will compare these three DSOs, and we will compare even a cube with a DSO. Thank you.